Hello and welcome. In this video, I just walk you through the very important concept and most interesting, and on the other hand, most frequently asked interview question that explain different phases with respect to UVM. Now we will try to see a little bit of theory, and after that we will try to put those theory into practice so that you will remember the concept forever. Now, what is the need of phases? Basically, phases are needed in order to provide the synchronization between various test bench components in the UVM. And this phases concept or phase concept is not there in SystemVerilog. This phase concept is new in UVM. Okay. Now we will by this example we will try to understand all the phases, and we will try to see how to print a topology. Very interesting. Now basically there are 9 phases, and the run phase, which is task in nature, will contain 12 sub phases. Okay, we will see what are those. Now first 9 phases are build phase, connect phase, end of elaboration phase, start of simulation phase. Then these first 4 phases are called as pre-run phase, pre-run phases. Okay, and after that run phase is there, which is task in nature, and after that extract phase, check phase, report phase, and final phase. And these 4 phases after run phase, they called as post run phases. Okay, all the phases are function except this run phase, which is task in nature. Why? Because this run phase contain delay, that's why it is task in nature. Okay, what are 12 sub phases of that run phases? 12 sub phases are pre-run phase, pre-reset, then post-reset. So first is pre-reset, then reset, followed by post-reset. After that, pre-configuration, then configuration, and post-configuration. Similarly, pre-main, then main, and after post-main. After that, pre-shutdown, shutdown, and post-shutdown. These are the 12 subphases of UVM run phase. Now see, we will try to see this example with the help of example. As you know, first 2 lines are mandatory in order to get access of UVM macros and UVM package, right? Now I have declared here a sequencer class. We will try to see all the phases, and we will try to put those phases here in example, and we will see how those phases are executed. Okay, now see, first one is a sequencer class, and this sequencer class is a parameterized class, but here we are not making it as a parameterized class because we are not declaring sequence. Okay, and this sequencer class is a component class in the UVM base class hierarchy. Hence its default constructor will expecting 2 arguments. You can see here string name and UVM component, and this is a factory recitation, tick UVM component details. And the responsibility of sequencer class is just routing the information from sequence to the driver. What it means, its responsibility is just a mediator kind of thing. It just take information from sequence and route this information to the driver, and this responsibility is completely protocol independent. What it means that if you are declaring sequencer for, let's say, a asynchronous FIFO verification, Or if you are declaring a sequencer, let's say for USB verification, then you will find that sequencer code is just of this 6 lines code. Okay, just we are extending sequencer, we are declaring sequencer and extending from UVM sequencer and factory registration and this default constructor, nothing more than of this. So it its responsibility is protocol independent, hence UVM developers comes with a common logic for this. Hence we need to just extend this from UVM sequencer, nothing more than of this. After that, as you know, driver class is here. Driver class is also parameterized one, and it is component class in the UVM base class hierarchy. So its default constructor will expecting two arguments. First one is string name and another is UVM component, and we need to register with the help of tick UVM component details. Okay, now see, just we are extending from UVM driver here, and the responsibility of driver class is to drive the stimulus which is generated by the sequence class to the DUT based upon DUT's protocol. Okay, and this driver also convert that packet data into pin level, or you can say in binary form, because our DUT is static in nature. We just understand that binary information. Okay, now see, this class is very simple. Driver extending from UVM driver, it is also parameterized one, but we are not making it as a parameterized here because we are not declaring sequence. Okay, now here comes the picture of phases. Okay, now we will try to see little bit of theory of all phases, and we will try to put those theory into practice. Now first one is build phase, and the responsibility of the build phase is to create or build all lower level components, and this build phase is executes in top down manner. Remember, very important, it executes in top down manner. There are two phases called build phase and final phase. These two phases are executes in top down manner, whereas all other phases are executes in bottom up manner, except that run phase. That run phase is a task which executes in parallel. Okay, in fork join. Now see, this is what the build phase. Just we need to declare virtual function build phase within parenthesis UVM phase super dot build phase, and we are not building any lower level component here. Just we are displaying a message that tick UVM info. This is what the ID build phase of driver class, and this is what the verbosity level UVM none. Now another phase is connect phase, and the responsibility of connect phase is to make a connection between all created components with the help of TLM port expo. Okay, and this executes in bottom up manner, and this is what the code for that. We are not connecting here, we are not creating any components, hence just I am displaying the message connect phase of driver, and syntax is something like this. Now see, another phase is end of elaboration phase. If any final time adjustment is need to be done, then we can do that adjustment in this end of elaboration phase, and this is also executes in bottom up manner. Or we can print a topology. What topology means? We can print the structure of our design in this phase. Okay, the syntax is same, function void end of elaboration phase within parenthesis UVM phase, and we are not doing anything, just displaying a message. Similarly, the start of simulation phase is there. If any banner information or any advertisement we want to print, we can print with this end of elaboration, end of simulation phase. Okay, and this is also executes in bottom up manner. Now another, and the syntax is very simple. start of simulation phase, within parenthesis phase, and we are not doing anything, just we are displaying the message start of simulation phase of driver class. And another, now it is very interesting, run phase. This is task because it contain delay, and the responsibility of run phase is to drive the stimulus to the DUT and monitor. Here driver drive the stimulus to the DUT and monitor capture the information from DUT based upon the DUT's protocol, and this executes in parallel manner. Okay, this run phase and pre and post phases, that 12 subphases of run phases, executes in parallel manner. Okay, now the syntax is task, run phase, UVM phase, and we are not doing anything, just we are displaying a message. Similarly, extract phase is there. The responsibility of extract phase is to extract the information from scoreboard and functional coverage. Okay, and it also executes in bottom up manner, and the syntax is something like function void extract phase within parenthesis UVM phase, and we are not doing anything, just displaying a message. Now check phase is there. This check phase is responsible for check if if the DUT behaves correctly or not, and identifies the errors, okay, which occur during execution, and this is also executes in bottom up manner. Don't worry, this is what a little bit of theory. You will enjoy this when we run the code, and we will see the how to print a UVM topology for this. Okay, now the syntax is something like function void check phase, and we are just printing a message that check phase of driver. Okay, now report phase is there, which just display the result of the simulation and also executes in bottom up manner, and the syntax is like this. Nothing, we are not doing anything, just we are printing a message. After and last is final phase. This phase, if any other outstanding action are there to complete, with the help of this phase we can make that final changes, and this phase is executes in top down manner. Remember that build phase and final phase, these are both two phases, executes in top down manner, and the syntax and for this is virtual function void final phase, phase and phase, and just we are displaying a message that final phase of driver. Now another class is monitor class. Monitor class is not a parameterized class, remember, and it is a component class in the UVM base class hierarchy. Hence its default constructor is expecting two arguments, string name and UVM component, and the responsibility of monitor class is to capture the information from the DUTs and broadcast this information to the scoreboard and coverage model. Hence it's contain analysis port. As you know that analysis port, when we are using, when there's one to many kind of transformation. Okay, now see, the another responsibility of monitor is to convert that pin level data into packet level form. Now this is what the monitor class, just we are extending from UVM monitor. As it is component class, we need to do the factory registration using tick UVM component details. Okay, and this is what the default constructor, and all the phases. No need to write all phases, I am just writing here in order for our understanding. Okay, and these phases are there based upon our test bench infrastructure or test bench architecture. Same phases as we have declared in the driver class. Okay, just go through these phases. Just I just made a change here, start of simulation phase, I'm just made as monitor class, rest of the code is same. Okay, same code, just printing message is different. Now see, this is what an agent class, and agent is also called as universal verification component. This agent is configurable one, means we can make agent as active agent or passive agent. based upon that config db parameter. Okay, is active is 1, then it is active agent, and that is active is in 0, then it can be passive agent. So active agent will contain all essential components. What are all essential components? Are sequencer, driver and monitor. But if that agent is made as passive, then it will contain only monitor. Okay, and the responsibility of this agent is to create all the handles or objects of the sequencer, driver and monitor, and will connect that sequencer and driver. Okay, and as it is component class in the UVM base class hierarchy, it contain its default constructor will have two arguments. One is a string name and UVM component, and we need to do the factory registration using tick UVM component utils. These are the instances of the sequencer, driver and monitor classes. Now in the build phase, we are building all these components. We are creating objects for this component. Now this is what not the case in real. Just we are not making that is active parameter. Hence we are just creating them. But if that is the case, is active parameter, then we need to blindly create this monitor, and we need to see that if is active parameter is active is 1, then we can create sequencer driver, else not. And this is the factories create method. We need to use this. If we are using this new construct, then factory overriding will not happen. Now this is what the connect phase. We are not connecting anything here, just a information I am printing here. Connect phase of UVM agent. Now see, this is what the syntax, how the connection is happen. I just telling you how that connection can be happen. We are just checking that is active. Okay, if mconfig dot is active is equal to UVM active, then only we are creating that sequencer and driver, and we are making the connection of them. And the syntax for connect is driver sequence item port dot connect within parenthesis sequencer item export. Remember, the connection is always done by using port, not by export. Okay, now as you know, port, this driver is contain port, whereas the sequencer contain export. Let me give you the diagram for this. Okay, now see, this is what the diagram. Sequencer will have this circle, it means that export or implementation port, and this driver is have this square bracket, it means it have port. Okay, so this is what the connection can be happen inside this agent, and this is what the active agent will contain all the essential components: driver, sequencer, monitor, and this monitor will have analysis port, one to many kind of. Okay, now see, this is what a agent class. Now see the environment class. The responsibility of environment class is to connect the scoreboard and agent together. If there are multiple agent, we can have agent top also, and it is also a component class in the UVM class based hierarchy. Hence its default constructor expecting two arguments, like a string name and UVM component, and we need to do the factory registration using tick UVM component. And this is what the environment name, class name, and we are just extending from UVM environment. Now instance for agent, and we are creating this agent here. We need to write agent instance in the environment class, and this we are doing using create method. Okay, within this build phase, we are building the lower level component. Lower level component is agent here, right? Agent, this handle is equal to agent class name, type ID, and create that object for the agent. Similarly, the next top component is test class. Okay, and the test class is responsible for connecting sequence and sequencer. together, and it is component class in the UVM base class hierarchy. Hence we need to do a registration using tick UVM component and its default constructor expecting 2 arguments, right? And similarly, it is a test class, is a top class, so it will have instance of the environment, and in the build phase we are creating that environment, object of that environment. The syntax is like object is equal to environment class name and this type ID create using factories create method. Remember, we are not using that function new, because if you are using, sorry, we are not using that new construct, because if you are using new construct, then overriding will not happen, factory overriding will not happen. Now this is what the task run phase. In this I am just giving 100 time unit delay, and with the help of this global stop request I am halting this simulation. Okay, very simple. Now this end of elaboration phase in the test, and with the help of this end of elaboration phase we will try to print a topology. How topology is printing we will see in some time. Now see, this is what the top module, it is static in nature, and it will contain the DUT instantiation and the interface definition. We are not displaying here because the module is not here, and interface is also not here. And within initial begin of this top we are just calling this run test, and within this parenthesis we are providing test, and after this run test all the phases starting from that build phase to final phase will start to execute. Okay, this is what a very simple. Now we will try to see how this code will run. Just go to transcript and write one line command qverilog file name. Okay, after some time we will get a result. Now see the result we are getting, and we will try to analyze the output. Very interesting. Now try to analyze the output. As you know, this is what the test class. Okay, as I have told you, test is a very top module for us, and after that top, okay, then environment is there, then agent is there, okay, then driver. Okay, and see, first build phase is executing, after that connect phase, then end of elaboration phase, start of simulation phase, run phase, extract phase, check phase, report phase, and final phase. This is what the phases are executing from top to bottom manner, right? This build phase will execute in top down manner. Now see, end of we are just saying that end of elaboration of driver, then monitor, okay, then connect phase, and this is what the output we are getting. Remember the top, just we just analyze this and see this diagram. Now see, the phases are build, connect, end of elaboration, start of simulation, run, extract, check, report, and final, and these are the pre-phase sub phases of this run phases. Okay, now see this diagram and check our output. Same we are getting. Okay, and this is what the architecture of UVM test bench. Top, inside that test, and inside that environment and agent, sequence and driver and monitor, and analyze this output by comparing this diagram. See, test is there, then top, then environment, test, this top, right, test, environment, and this agent will sequencer, driver, and monitor. Okay, the sequencer, driver, and monitor. This is what the output we are getting. Now in order to print a topology, how to print that topology? It is very simple. Now in the test, or you can take in the environment, in the end of elaboration phase, just write UVM underscore top dot print topology, so that you will get the topology result. Now run the code and we will see how the topology is printing. Very important and very simple on the other hand. Try to analyze the output. Now see, we are getting topology. This is what the topology we are getting. Test, right? Top test module. After that environment is there. Okay. Agent is there, which contains driver, monitor, sequencer. Okay. This is what the topology we are getting of our test bench, what we have declared here. Very simple. Now, or you can print using tick UVM info. This is ID. This dot sprint. Sprint means structure print, and you can print with the help of this also. Just run the code and we will see the same output we will get. Very important, very interesting. On the other hand, just try to run this code by typing all code and you will find it quite interesting and quite easy. Okay, as UVM is all about practice, you need to practice only and then you can become expert. Now see, this is what the topology, same topology we are getting. Test, environment, then agent, then driver, and the monitor, sequencer. Okay, this is what the topology we are getting. So this is what all about UVM phases, how phases are executed in top-down manner and bottom-up manner, and little bit of a theory about that phases. And we will try to see another interesting question, very interesting question. Just analyze this test bench architecture of UVM, and the question arises is, explain that UVM, in the UVM, test case writer are less depend upon test bench developer. Let me repeat the question. The question is, explain that the test case writers are less depend on test bench developer. Now just analyze this test bench architecture and you will get the output. Pause the video and try to think the answer for this, else I will reveal the answer for this. And the answer is very simple. Now if you are carefully observing this test bench architecture, you will find that the sequence is there, right, in which actual transition is happening. This sequence is a part of test, whereas sequencer, driver and monitor are the part of this environment class. So this is what the test bench, this is what the test bench developer responsibility, and this is what the test case writer responsibility is, to write the sequences. So this is what test case writers are less depend upon test bench developer in this case. While in case of SystemVerilog, this is not the case. Test bench developers are and test case developers both are dependent on each other. So with the help of this UVM, test case writers can become a less depend upon test bench developer. So I hope with this you have understood the concept of phases and all the phases, how all the phases are executed, and very interesting topic, how to print a topology. Okay, and that question that explained that UVM test case writers are less depend upon test bench developer. And also I hope that you enjoyed this video. So thanks for watching. Thank you.